Okay, last but not least, we have horizontal dilations. So same steps, but notice that this time it's inside the argument. And also notice that when we are inside the argument, it's the opposite. So instead of a 4 that appears in both of these are flipped fractions. So essentially opposites of each other. Because technically 4 is 4 over 1. So then you're going to flip it around and multiply the x value by 1/4. Okay, so let's take a look at how this changes each of our points. We have 0, 1 as your first point. And we're going to multiply that 0 by 1/4. The y value remains unchanged. So 1/4 times 0 is just 0. Well, anything times 0 is just 0. And the y value is still there. And then for 1, 2, 1/4 times 1. And then the y value remains unchanged. And then this is going to give us 1/4 times 1 is just 1/4. Because anything times 1 is just the anything. Last but not least, we have 1/4 times 2, 4. The y value remains unchanged. Remember, the y value remains unchanged when you're doing horizontal anything. So horizontal means we're changing the x value. In this case, 1/4 times 2 is 2/4, which simplifies to 1/2. Okay, so we got our 3 points. Let's plot them. 0, 1, 1/4, 2, 1/2, 4. All right, so you're noticing everything's really smushed together. So it's smushed because this number was bigger than 1, which makes this fraction that we multiply it by very small. So that's why everything gets smushed. Okay? So since it's smushed, it's a little bit harder for us to tell what happens to our asymptote. So let's write our equation so we can figure that out. Okay, so g of x is equal to f of 4x. So anywhere you see x in the original equation, you're just going to replace it with 4x. So 2 to the power of x becomes 2 to the power of 4x. All right, and technically there is a plus 0 at the end of this. So that will be our horizontal asymptote, which is right over here in yellow. I know I picked yellow, it's kind of hard to see, but the asymptote's not really part of the graph. It's just a guideline for us, so we know that our graph doesn't go past that. All right, so it's very squished, so this graph's not going to look very great, but that's essentially what it looks like, a very smushed graph. And I guess I should draw you the happy faces. So if you have an original circular happy face, the thing about these horizontal dilations is that the width is going to change, but the height is not going to. So you can smush it. Notice it has the same height. Or you can compress it. Or, sorry, you can smush it / compress it, which is what I just drew over here. Or you can stretch it out. But notice that the height stays the same. The height stays the same for horizontal dilations because the height is the y value. The y value is going to stay the same when you're doing horizontal dilations because when you do horizontal anything, you are just changing the x. Okay, so this is like where you pull it in the x direction. So you stretch it wider or compress it to be less wide. Okay, so that was number 5. Let's go on to number 6. And you will notice that we are doing 3 to the power of x and then multiplying, or now it's f of 1/2 x. So remember that this number and the number that we put in front of the x here is going to be flipped fractions. So flipped version of 1/2 is now going to be 2 over 1. That's supposed to be a flipped arrow, but that doesn't really look like it. There we go. Flipping it around becomes 2 over 1, which is just 2. So it becomes 2x, comma, y. So we are going to multiply every x value by 2. Let's start doing that. So 0, 1 becomes 2 times 0, 1, which becomes 0, 1 still because, well, 0 times anything is just 0. All right, next one is 2 times 1, comma, 3. So 2 times 1, well, anything times 1 is just, the anything. So it becomes 2, comma, 3. Oops. The last one is 2 times 2, comma, 9. And 2 times 2 is 4. So we have our 3 points. Let's plot them out. Okay, so we have our points there. Let's write out our equation so we can find the asymptote so that we can graph our graph. So for the equation, literally just write 1/2 x anytime you see the x. So g of x is equal to 3 to the power of 1/2 x. So it's no longer 3 to the power of x, it's 3 to the power of 1/2 x. And then technically you can see that there's a plus 0 here, making your horizontal asymptote 0, which means right over here, just drawing my dotted line for my asymptote. And now let's connect it. Okay, so just make sure you stay on top of your dotted asymptote line. And that's how you do horizontal dilations. So if you have any questions, please let me know. Other than that, you are just doing the skills practice assignment over here. So numbers 13 through 16 and then 19 through 22. And that's pretty much it. Call me over if you have any questions.